All right, our third lesson in polynomials is multiplying. So last lesson we learned adding and subtracting. This one we're going to learn how to multiply polynomials. Again, something that I bet you have known for a very long time. So as a warm-up, let's think about some multiplying. Okay, which would you rather have? A pool that's 40 feet by 9 feet by 4 feet, or a pool that's 7 yards by 4 yards by 2 yards? Pause your video, see what you can do. All right, so obviously to figure out what kind of a pool you want, we're really thinking about volume, right? I mean, a bigger pool would be better, unless you think about having to clean it and all that, but we'll just assume that a bigger pool is better. So remember that volume of this kind of pool would be length times width times height, right? Or we're going to take all three of those numbers and multiply them together. But be careful. So if I wanted to find the volume of this first pool on the left, I'll say 40 feet by 9 feet by 4 feet. So the volume would be 40 times 9 times 4, right? So this volume would be 1,440 feet cubed, right? Feet times feet times feet, feet to the third power. Now, if I went over to this other one and I just did 7 times 4 times 2, I could get a volume, but I couldn't compare it because this is in yards, right? This is in yards. My other one was in feet. So in order to be able to compare these two, I'm going to change these yards into feet. Now remember, 1 yard equals 3 feet. So 7 yards would equal 7 times 3, which is 21 feet. 4 yards equals 4 times 3, which is 12 feet. And 2 yards would equal 2 times 3, which is 6 feet. So in order to find my volume and be able to compare them, I'm going to multiply those three numbers. So the volume for this one would be 21 times 12 times 6. Or in that case, it would be 1,512 feet cubed. So if I wanted to compare the two, which I do in this case, I got to make sure that they have the same unit. So 1,512 cubic feet, whoops, would be better than 1,440 feet cubed. But if you had just looked at those original numbers, you'd be like, whoa, that second one is smaller. Ooh, watch those units, right? Okay, so let's start thinking about multiplying with our polynomials here, okay? So remember, if you have a number outside of a parentheses, I'm sure you know exactly what to do with it, right? You distribute. Same thing here. So here I have a monomial, right? One term outside of a trinomial. 1, 2, 3 terms. Now, if that was just a plain old 4, that would still be a monomial times a trinomial, right? And you know exactly how to do that. So just remember, as you're doing these, it works exactly the same as all the multiplying you've been doing, but don't forget about your exponent properties. So here, my first one, I'm going to say 4m times 5m squared. 4m to the first times 5m to the second. 4 times 5 gives me 20. M to the first times m to the second. M to the first times m to the second would be m to the third power. Remember those exponent properties back from Unit 5, okay? Actually, Unit 4. I apologize. All right. Now we're going to distribute to the second term. So I have 4m to the first times m to the first. It's kind of like the invisible 1 here, right? So I'm going to get 4m to the second. Be careful, that's one that catches people all the time. M to the first times m to the first is m to the second. Okay. And then I'm going to distribute it to my last term. 4m to the first times negative 6 would be negative 24m. Or m to the first, it's up to you. And as just like we've been doing in all the other ones, making sure we write our answer in standard form, but I see that this is already m to the third, m squared, m. That's it. You multiplied polynomials. You've been doing that all the time, right? Hopefully it's not too scary. All right, so here we go again. Negative 7h squared times 3h squared. Negative 21h to the 4th, right? Add those exponents. Then I have negative 7h squared times negative 8h to the 1st. Negative 7 times negative 8 is positive 56. H to the 2nd times h to the 1st is h to the 3rd. Add those exponents. And then distributing my 1 last time, negative 7h squared times negative 1, negative 7 times negative 1, positive 7h squared. 432, already written in standard form, good to go. Okay, same idea here. Maybe you want to take a shot at these on your own, right? Pause your video, see what you can do. So when I distribute my m squared to 3m to the 1st, m squared times 3m to the 1st would give me 3m to the 3rd. Be careful there, right? Okay, then I'm going to distribute m squared times negative mn. Now remember, I'm just going to combine my m's. M squared times negative m to the 1st n would be m to the 3rd n, right? I'm going to combine my m's, get m to the 3rd. M squared times negative n, I'll have a negative m squared n. The one on the outside was an m, the one on the inside was an n. I just write them next to each other because I am technically multiplying them. All right, now on this one, we might have to change the order for standard form because I see an m to the 3rd for my first term. M to the 3rd n to the 1st would be a degree of 4. That needs to be first. M squared n would be a 3rd degree as well. So in order to write it in standard form, I got to take that 4th degree one and write it first. Negative m to the 3rd n, or n to the 1st, it's up to you. I'm going to go with minus m squared n after that, and then plus 3m to the 3rd. But it really doesn't matter on those last two because they're both the same degree. Okay, let's see what we got on this one. Hopefully this one wouldn't be too bad for you. Negative 6a to the 4th times 2a squared, negative 12a to the 6th. Negative 6a to the 4th times negative 10a is positive 60a to the 5th. Remember, a to the 4th times a to the 1st, a to the 5th. That one was a tricky one. Be careful of that. And then negative 6a to the 4th times 4 would be negative 24a to the 4th. 654, that one is in standard form already. All right, hopefully that was pretty familiar for you. I'm going to kick it up on you a little bit here. So how about we make that monomial a little bit more complicated. So 4x to the 3rd y squared times negative 1x squared y. So let's see, 4 times negative 1 is negative 4. X to the 3rd times x squared would be x to the 5th. Y to the 2nd times y to the 1st would be y to the 3rd. Okay, so remember, we're multiplying those coefficients in front, then we're adding exponents of any of our like bases. Man, this is really bringing Unit 4 back at you. So hopefully you remember all those exponent properties because they don't go away. All right, now we're going to distribute to my second term here. 4 times 2 is 8. X to the 3rd times x to the 1st is x to the 4th. Y to the 2nd times y to the 1st gives me y to the 3rd. So I've got 8x to the 4th, y to the 3rd. Watch those exponents. And distributing to my last one here. 4 times negative 5 is negative 20. X to the 3rd times x to the 1st is x to the 4th. Y to the 2nd times y to the 2nd is y to the 4th as well. All right, let's see. Let's just double check for our standard form. I see 5 plus 3, my first term has a degree of 8. 4 plus 3, my second term has a degree of 7. 4 plus 4, my third term has a degree of 8. So I do have to switch the order of these two terms to be in standard form. I can leave my negative 4x to the 5th, y to the 3rd at the beginning. Then I need my negative 20x to the 4th, y to the 4th. And to be in standard form, my last one has to be 8x to the 4th, y to the 3rd. And you could technically switch the order of those first two terms. Whichever one you want to come first, if they have the same degree, is perfectly fine. All right, so just remember your exponent properties. We did a whole unit on exponents for a reason, and they're coming back into play right now, so don't forget about it. All right, now here, I have more than one distributing, but I know that you guys can handle that, right? Yeah, it's a little bit different, but you got this. So we'll distribute the 4y to the 6y. 4 times 6 is 24. Y to the first times y to the first is y to the second. Watch that. That one's a tricky one. Okay. And then I have 4y times 1 will just be 4y. Okay, now over here, I've got negative 2y squared that I'm going to distribute. Whoopsies. That I'm going to distribute to this y to the first, right? So I'll have negative 2y to the 3rd. Watch that. And then I have negative 2y squared times negative 2, which is positive 4y squared. Now I know in the last, when we were doing adding and subtracting, I really emphasized writing the like terms underneath each other, and you definitely could do that on this one too. I kind of forgot about it, so I didn't do it right away. But now look for like terms to combine. If you have that more than one distributing, double check that, okay? I'm also going to see if I can't write this in standard form as we go. So I see I have y squared y to the 3rd. So negative 2y to the 3rd would have to come first. That's my highest degree. After that, I'm going to combine my 24y squared plus 4y squared to get 28y squared. And then my positive 4y, I have nothing to combine it with, so it's just going to be plus 4y. So remember, if you have more than one distributing to do, check for like terms to combine. All right, so here's a situation where you might use that multiplication idea. So Christelle is making a planter box with a square base. She wants the height of the box to be 3 inches more than the length. Write and simplify an expression for the volume of that planter box. So a planter box is just like a box we plant flowers in, right? It's going to have a square base. So if we start with this, we know that the bottom would be a square. And then, oh boy, this is not how I normally draw them. Okay, let's say this. Here's my planter box. And I know my base is going to be a square. That maybe looks a little bit more like it. So if I know it has a square base, let's say both of these are x, right? Because I know that all those sides on the bottom would be the same. But it says that the height of the box, height, is going to be 3 inches more than the length. So if the length is x, I want it to be 3 inches more than that. So that would be x plus 3. All right, and then I want to find the volume. Boy, good thing we did that warm up for volume, right? For volume, I want it to be length times width times height, right? Or in this case, I'll have volume will be x times x times x plus 3. Now be careful. When you have more than one term, you need to make sure that you put that polynomial in parentheses. Monomials don't have to be in parentheses. Polynomials have to be in parentheses because we want to multiply by that whole polynomial, not just the first part. So anytime you have more than one term, you gotta have parentheses. Now, for some reason, multiplying these three things throws people off all the time. Totally normal. Happens all the time. You try to distribute and distribute and distribute. But remember to multiply three things. Pick any two to start with. Get an answer and multiply it by the third. So pick any two to start with. So I'm going to pick the easy two, right? I'm going to multiply those first two together. X times x gives me x squared. And then I keep that third one exactly how it is. So I have x squared times x plus 3. After you've picked two to multiply together, now multiply by the third one. Okay, so don't try to multiply 3 all at once. Can't do it. Pick two, get an answer, then multiply it to the third one. So now in this case, I have to start distributing. So I'll get x squared times x to the first is x to the third. X squared times 3 is 3x squared. So my volume is x to the third plus 3x squared. All right, so just seeing how you can do those volume idea with your polynomials. So that's why we brought that up in the warm-up, and it really kind of made sure you understood how to do this volume one here. So volume is a really common way where you would see some multiplying when we're talking about polynomials. Area is another. So write and simplify an expression for the area of this rectangle. Remember, area is just length times width. So in this case, area equals 4x, that's a monomial, right, times x plus 7. Now this is a polynomial. There's more than one term, so you have to make sure that you put that x plus 7 in parentheses. You have to. Now this looks exactly like the ones we've been doing before, so here I just have to distribute. So I have area equals 4x squared, right? X to the first times x to the first is x squared. 4x times 7 would be 28x. So make sure you use those parentheses so you distribute that 4x to both parts. Okay, hopefully that helps you. Remember, use that distributive property to get rid of your parentheses. Watch your exponent rules. If you have more than one more than one distributing, make sure you simplify that answer to combine your like terms. And don't forget about standard form. And I showed you a couple different ways where that multiplying will show up in a real life situation.